Assalamualaikum and hi to my lecturer Encik Asridin and my fellow friends. Today I will present my assignments of electrics titled Logic Gates. Introductions. Logic gates are the basic building blocks of any digital system. It is an electronic circuit having one or more than one input and only one output. The relationship between the input and the output is based on a certain logic. Based on this, logic gates are named as AND gate, OR gate, NOR gates, and etc. Okay, first type of logic gates. The first one is AND gate. A circuit which performs an AND operation is shown in figure. Yes, an input and more than equal to and one output. The AND gates, we also can assume that there is two input and one output. The two input will be times, is shown as in the equations. Y equals to m times b times c. The result for the truth table shown as when the A input is 0, B input is 0, the answer will be 0. 0 times 0 is 0. When A input is 0, B input is 0, is 1, the answer will be 0. 0 times 1 is 0, and so on. Next is OR gates. The circuit which perform an OR operation is shown in figure. It has input and more than equal to 2 and 1 inputs. The OR gate has 2 input and 1 output, as shown as. Let's see the equations. Y equals to A plus B plus C. So it's like A, the input will be, the input A will be plus B, as shown as truth table. 0 when the input is 0, we input A is 0, the input B is 0, the answer will be 0. 0 plus 0 is 0. When the input is A is 0, input B is 1, the answer will be 1. 0 plus 1 is 1, and so on. NOT gate. NOT gate is also known as inverter. It has one input A and one output Y. NOT gate also, it can be also called as inverter. The input that through the NOT gate will be inverted. Let's say when the input A is 0, the answer Y will be 1, because the input will be inverted. When input A is 1, the output will be 0, and so on. NAND gate. A not AND operation is known as NAND operation. It has an input and more than 2, more equal to 2, and one output. The question is why A NAND B NAND C. NAND gate is also called as NOT AND gates. It's a combination of NOT and AND gates, as as shown as in the truth table, input A is 0, input B is 0, the answer will be 1. When 0 plus 0 times 0, it should be 0, but it is invert into 1. When the input A is 0, input B is 1, it should be 0, but the NOT gate will invert it into 1, and so on. Next is NOR gate. A NOT OR operation is known as NOR operation. It has an input and more than equal to 2 and 1 outputs. The equation is y equal to A nor B nor C. NOR gate also can be called as NOT OR gates. It's a combination of NOT gates and NOT gates and OR gates. The truth table for this gate is when the input O 0, the A is 0, B is 0, the answer will be 1. 0 plus 0, it should be 0, but we will invert, the NOT gate will invert it into 1. 0, when the input A is 0, input B is 1, the answer is 0. 0 plus 1, it should be 1, but the NOT gate will invert it into 0, and so on. XOR gates. XOR or XOR gate is a special type of gate. It can be used in the half adder, full adder, and subtractor. The exclusive OR gate is abbreviated as XOR gate or sometimes as XOR gate. It has an input and more than equal to 2 and 1 output. The equation is A XOR y equal to A XOR B XOR C. The input is when the input A is 0, the input B is 0, the answer will be 0. 0 plus 0 is 0. When the input A is 0, input B is 1, the answer will be 1, and so on. Next is XNOR gates. XNOR gate is a special type of gate. It can be used in the half adder, full adder, and subtractor. The exclusive NOR gate is abbreviated as XNOR gate or sometimes as XNOR gate. It has an input and more than equal to 2 and 1 input. The equation is y as A XOR gate and B XOR C. For the truth table, when the input A is 0, input B is 0, it should be 0, but the NOT gate will be inverted into 1. When input A is 0, input B is 1, the answer is 0. It should be 1, but the NOT gate will invert into 0. This one is the example and answer for one's questions. For this circuit, there will be 3 outputs. It's a combination of AND gates, NOT gate, OR gates, and another AND gate. as you can see, when the input A is 0, input B is 0, input C is 0, the answer will be 1. When input A is 0, input B is 0, input C is 1, the output will be 1. When the input A is 0, input B is 1, input C is 1, the output will be 1. That's all from me. Thank you. Thanks for watching.